Okay, for number 2, I have a rational function that I want to graph. So the bottom is already factored for me, but I need to factor the top so I can find all the important information easily. In the top, I can take out a GCF first. All of these terms share a -2 in common, so I could take out a -2, and then I'd have -2 times x squared plus x minus 12. And then if I have that, I can separate it into that x squared plus x minus 12. I can separate it into x plus 4 times x minus 3. And those two numbers, 4 and -3, add up to +1 and multiply to -12. And then I know I have in the bottom x minus 3, x minus 2, x plus 4. So I see that my x minus 3's cancel each other out and the x plus 4's cancel each other out. And when I simplify fully, I end up with -2 over x minus 2. That's my final equation that I'm going to use to find most of the important information. For the wholes, I know I have a whole for what the x values that would have made the denominator 0. So those points are going to be undefined, and they're going to have holes on them, open circles to indicate they're not included in the graph. So x is 3 is one of them, and so I need to solve for what f of 3 is. In this equation here, I'm going to plug in 3, and I'm going to get -2 times 3 minus 2, which is -2 over 1, or just -2. And then the other whole is at -4, comma, so I'm doing f of -4, so that's -2 over -4 minus 2 is -6, that's 1/3, so -4 and 1/3. The vertical asymptotes, I look at what's left over, what's in the denominator. I have x minus 2, so the x value that would make that 0 is 2, so I have a vertical asymptote as x is equal to 2. The domain is based off of the wholes and the vertical asymptotes. So from least to greatest, the x values that are not included in the graph are -4, 2, and 3. And so my domain is -infinity to -4, union -4 to 2, union 2 to 3, and then 3 to infinity. And that's my domain, because I have to exclude these 3 values, and that means I have 3 breaks in my domain, which means I should have 4 intervals that explain it. I want to circle circle which one this graph has. Sorry. A horizontal asymptote or oblique asymptote. Oblique just means slant. It's a different word for slant. So slant asymptote, or horizontal asymptote in this case, I have the highest power in the numerator is x squared, and the highest power in the denominator is x cubed if I was to FOIL this. And so that means it's bottom heavy, which means it's a proper fraction, and I have my base situation, a horizontal asymptote at y equals 0. So the end behavior is described by that horizontal asymptote or the oblique asymptote. And I say the limit as x goes to positive or negative infinity of f of x is equal to 0. The y-intercept I know is when I plug in 0 for x. So I look in, actually I gotta use the, I could just plug it into this equation, sorry. And I have, so f of 0 is going to be -2 over -2 or +1. So it's 0, 1. And then I have no zeros because there's no way for me to make that numerator equal to 0. So none for my x-intercepts. And then I'm going to plot this important information. So I have holes at 3 and -2. So 3, -2 right here. So I put an open circle. I have a hole at -4, 1/3, -4 and 1/3. So like right here. And then I have a vertical asymptote at x is equal to 2. So vertical asymptote at x is equal to 2. Then I have a horizontal asymptote at y is equal to 0. And then I have a y-intercept at 0, 1. So I should be able to see that as I go to the left of that y-intercept, I should be approaching the horizontal asymptote. I shouldn't be going through the horizontal asymptote because I didn't have an x-intercept. So I shouldn't be going through y is equal to 0. And then as I go to the right, I know I'm getting closer and closer to that vertical asymptote. On the other side, I know that because I don't have any repeating factors in the denominator, I'm approaching that vertical asymptote in the opposite direction, so I'm going downwards to get to it. And then as I go to the right, I am approaching the horizontal asymptote. I'm not going through the horizontal asymptote at any point on the right because there's no x-intercept there. So that's my graph.